Welcome to this video lecture on the topic capacitance between coaxial cable and energy stored in the capacitor. So in this lecture we are going to discuss about the calculation of capacitance of a coaxial cable. So first of all we are going to consider the coaxial capacitor as shown in this diagram, where it consists of two concentric conductors separated by a dielectric. So the two conductors have the radius of small a and b respectively for inner radius and outer radius, and the permittivity of the dielectric is epsilon. And consider the length of the cable as L for calculation. So the inner conductor carries a charge density of rho L in the surface and the equal and opposite charge density of minus rho L on the outer conductor. So the total charge is calculated as charge density multiplied by the length of the conductor, because the line charge density is rho L. So consider the cylindrical coordinate system for calculating the cylindrical capacitor. Because coaxial is the cylindrical one, so we are going to consider the electric field for in radial distance from inner conductor to outer conductor, and for infinite line charge the electric field is given in this equation, where rho L divided by 2 pi epsilon r, where rho L is the line charge density. So the electric field is directed from inner conductor to outer conductor. So we are going to calculate the potential difference between the two conductors. So V equal to minus integral E dot dl. So limits are B and A. So substituting the electric field value, and dl is replaced with dr into ar, because it is electric field is directed from radial direction. So solving the integration, we get 1 by r is the integral, remaining are constant. So 1 by r integration is ln of r. So substituting the limits a and b, we get ln of a by b. So this is the potential difference. So there is a minus in the equation, so we change the ln as b by a. So finally substituting the value of charge and potential difference C equal to q by v, we get capacitance. So 2 pi epsilon L divided by ln of b by a farad. So this is the capacitance of the coaxial cable. So next part we are discussing the energy density of a capacitor, because the energy stored in the capacitor has made many application. So it is the energy stored in the capacitor is the electrical potential energy. So it is the energy density is the measure of the amount of energy stored in a given volume of the capacitor. So it is an important parameter in designing the capacitance. So energy stored in a capacitor is calculated for the parallel plate capacitor as energy stored is given by 1 by 2 volume integral of d dot product with E, where D is the electric flux density and E is the electric field intensity. Next, this is the equation for energy stored in a capacitor, where we are going to take electric field intensity 1 by 2 integral epsilon E dot E as E squared. Next, substitute E equal to V by D. So we get the volume integral values A into D. So energy stored derived as half CV squared joules. So this is the energy stored in a capacitor. So for energy density, it is the energy stored per unit volume. So previously we calculated energy stored in the capacitor, it is then energy density. So we are getting as 1 by 2 integral of D into E joules per meter cube. So we are discussing the factors affecting the energy density of the capacitor. So the capacitor is determined from the dielectric material. So the type of dielectric material greatly influences the capacitor and its energy density. So for example, material with a high dielectric constant can store more energy per unit volume, so resulting in higher energy density. And next parameter is the geometry and design. So geometry and design of a capacitor, including its shape, size and arrangement of the plates, can impact its energy density. So larger surface area of the plates and the smaller separation between them results in higher energy. Next is the operating voltage. The voltage applied to a capacitor directly affects the amount of energy. it can store. So with higher voltages resulting in higher energy density, but however the capacitor have a maximum voltage rating, because beyond which the dielectric may break down and the capacitor may fail. So the applications are the audio equipment, uninterruptible power supplies, camera flashes, pulsed loads such as magnetic coils and lasers use the energy stored in the capacitor. So assessment questions. Thank you for listening.